This video is an overview of Pokemon automation and on how to set it up. My goal with this video is to make a beginner-friendly and comprehensive setup guide. This video will go over the following topics. What is Pokemon automation and briefly how it works? What hardware is needed and what you'll need to buy? Then we'll discuss how to set up the microcontroller and computer control programs. What this means, we'll talk about later. Lastly, we'll discuss basic troubleshooting and where you can ask for help. Chapters and timestamps will be in the video description. So what is Pokemon automation? This is open source software that allows you to automate actions on your Switch. This uses a microcontroller like an Arduino and a computer. The way it works is that the microcontroller emulates a third-party controller and sends button presses according to the program. As a side note, Brian UUU's autocontroller program is another program that automates Pokemon. It has a similar setup with similar hardware. Some people confuse autocontroller with Pokemon automation, and I wanted to highlight that they are different programs. So what can Pokemon automation do? With this software, you can automate repetitive portions of the game. These programs can do things such as shiny hunting, egg hatching, resetting for specific IVs for legendaries. You can also farm for money, EV reduction berries, EXP candy. For Scarlet and Violet in particular, you can farm for Terra Shards, Gimme Cool Coins, Blueberry Points. With automation, all of this can be done while you sleep or while you're at work or at school. Here's an example of one of the programs for Scarlet and Violet. It's called Egg Autonomous. It automatically breeds Pokemon for specific IV spreads or for shinies. The way it works is that it will automatically make an egg power sandwich, collect 30 eggs, and hatches them. It then keeps the hatched Pokemon that meets your requirements and releases the rest. And it can reset the game if there are no Pokemon to keep in those 30 eggs, therefore saving sandwich ingredients. It can also completely run unattended for many days without intervention. This is just one program from Pokemon Automation, but it can do so much more. I'll post a link to the list of programs in the video description. Pokemon Automation has two types of programs, microcontroller and computer control. With microcontroller programs, it can run on the Switch and Switch Lite. Less hardware is needed, less steps are needed to set it up. It blindly sends button presses, less programs are available, and the programs are less reliable. In contrast, our computer control can only run on a full Nintendo Switch. A few more pieces of hardware are needed. A few extra steps are needed to set it up. It takes in video input so it can make decisions based on what's on screen. More programs are available. Most new development is done with the computer control programs, and the programs are more reliable. This video is a step-by-step walkthrough of all the steps needed to set up computer control automation. If you prefer a written guide, refer to the wiki on Github. This video is heavily based on these written guides, and I will be referring to them throughout this video. All links will be in the video description. First, we'll talk about the hardware. Here's the list. For specific details, we will talk about this in the next slides. In terms of where to buy the components, a lot of the components for this build can be bought at the places listed here. So DigiKey, Mouser, Amazon, or local hobbyist electronics shops. Outside of North America, DigiKey, Mouser, and Amazon are still options, but for more options, refer to the Reddit link posted. In the video description, I will also post links to where you can buy the hardware. First, you will need a computer running 64-bit Windows. Basically, your computer needs to run a full version of Windows. If you already have a modern computer with Windows 10 or 11, you will most likely be okay. If you're running Windows 11, you almost certainly have a 64-bit operating system. Same if you have 6 GB of RAM or more. Support for Mac or Linux is limited. It can be done, but you need to know how to run command line build scripts, which is outside of the scope of this video. So this video assumes you have a Windows computer. The automation programs do use computer vision to read the Nintendo Switch video output. So the computer needs to be moderately powerful. The recommended minimum is a computer with a dual-core CPU at 3 GHz, no older than 2015. If you intend to control more than one switch, you will need a more powerful CPU with more cores. If you don't already have a suitable computer and are on a budget, I recommend that you don't try to run the software. In particular, you want to avoid being in a situation where you're limited by your budget, so you buy an underpowered computer and it ends up not working properly for this anyway. Next, you will need a Nintendo Switch with a dock. The official dock is preferred. Some third-party docks do work, but not all of them work well. USB-C hubs can also work in lieu of a switch dock, but it can also introduce issues such as problems with power delivery, so the official switch dock is preferred for most people. Switch Lite cannot output video and therefore cannot run any programs that require video capture. If you plan to automate, I recommend only doing this with a Nintendo Switch, either version 1 or version 2, or a Switch OLED. Note that you can use a regular Switch. It does not need to be hacked. No modification of the Switch are necessary. Next, you need an Arduino Leonardo. This is a microcontroller. There are multiple types of microcontrollers, for example, the Pro Micro, the Teensy, the Uno. The Arduino Leonardo is recommended for beginners, and that's what I will use for this video. I recommend getting one with headers, which I will talk about in the next slide. There are also unofficial Leonardo clones, which also work, such as from Key Studio. Headers are a form of electrical connector. They allow you to connect jumper wires to them, which we'll talk about later. For the Arduino with headers, you can see a row of black connectors across the top as well as the bottom. If you get the Arduino without headers, you'll need to use different hardware to connect your board to your other components. So for beginners, I recommend getting the Arduino with headers unless you know what you're doing. There are other options for the microcontroller. This video guide assumes you bought the Leonardo, but I'm mentioning these others just for completeness. So other options include the Teensy and Pro Micro. No other microcontrollers are recommended. The Arduino Uno R3 technically does work with Pokemon automation, but it has various issues that can be hard to troubleshoot. It also can't run all the computer control programs, so it's not recommended. Next, you need a USB to TTL serial cable. It's also referred to as a UART cable in the guide on GitHub. They recommend the Adafruit cable pictured here. It uses the CP210X drivers from Silicon Labs, which we'll talk about drivers later. Just as a side note, Adafruit also sells a more expensive cable, the FTDI serial TTL232 USB cable. This uses different drivers. Some of the developers on Discord say that FTDI can work, but it isn't recommended by the guide and it's more expensive, so I would stick with the cable with CP210X drivers. If you're unable to get the Adafruit UART cable, you can get CP210X modules instead. Ensure it uses the CP210X chipset, so for example the CP2102. Make sure it does not use the prolific chipset, so for example PL2303. So if the product page doesn't mention CP210X or CP2102, then I wouldn't buy it unless you know what you're doing. Next, you need male-to-male jumper wires. We need a way to connect the wires from the UART cable with the header pins on the Arduino Leonardo, both of which are female. So we need male-to-male jumper wires to make that connection. Make sure they are not female-male or female-female. So it should have a pointy end on both ends of the wire. Another consideration is wire thickness. 22 gauge is preferred, but 24 gauge is also fine, which is what I have. Gauge refers to wire thickness. Lower numbers mean thicker wire. If the wire is too thick, it won't fit in your Arduino. If it's too thin, it won't make a solid connection. So here are some pictures of what the male heads looks like, as well as some of the female heads. Next, you need a video capture card. This takes the video signal from a device like the Switch and converts the signal into a format the computer can understand for recording. For the purposes of Pokemon automation, the cheap capture cards work. Make sure the capture card is capable of a video output resolution of 1080p at 30 frames per second. One downside with cheap cards is you may get slight input lag. So if you want to use your capture card for other purposes, such as streaming gameplay, you should consider getting the more expensive cards with features such as HDMI output to display on your TV, as well as pass-through for minimal input lag. Personally, I have a cheap one. I don't notice much lag while playing Pokemon, and overall it works fine for automation. Next, you need a USB-A to micro USB cable. You may already have one, in fact. Prior to USB-C, this type of cable was commonly used for charging phones and other electronics. But the cable needs to support data transfer, not just power. So if you're not sure if the cable that you're using supports data transfer, you should consider swapping out the cable when you're troubleshooting. Next, you need an HDMI cable. This allows you to connect the switch dock to your capture card and/or TV. Again, you may already have this. It comes with a switch. And so once again, here's a list of all the hardware that is needed. And there are links in the video description to online sites where you can buy these components. Once you have the hardware, we can set up the microcontroller. Go to the GitHub wiki for part 3, microcontroller. Link will be in the description. So first we will download and install WinAVR. So we'll download this. I already have it downloaded. So we're going to install that. Click yes, okay. Next, I agree. We'll install it to the default location in the C drive. Install. So while we wait for that, let's go back and go to the next step. So now we want to download a QMK toolbox. So we'll open that link. We want to download version 0.1.1. So click this arrow next to assets, download QMK toolbox exe. So we'll save that. Just as a side note, QMK had faulty versions around 0.2 that have now been fixed in recent iterations, so it's fine to use the latest version. However, I'm using 0.1.1 in this video since I know it works. Next, download the Arduino program. We'll open that link. We'll just download the latest version, download this zip file here. Save. So now let's open that folder where everything is downloaded. We're going to extract this zip file. Make sure the extracted zip file is not located in a Microsoft OneDrive folder. So now you will use this hex generator. When you first open the hex generator, you'll get a warning from Windows Defender. This software is open source, so if you trust them, you can click Run Anyway. Change the board type to Leonardo. Select the program as being TurboA. So I'm going to save and generate the hex file. So now it's generated. And so now when we go back to this folder, we will see that this hex file has been generated. Now let's open QMK. So let's go back to the QMK toolbox exe. Open that up. When you first open it, you'll get a pop-up asking you to install the drivers. Click yes. If you don't get that pop-up, you can go to Tools and install drivers there. The drivers have already been installed, so I won't do that right now. Now you need to click Open, select the hex file that we generated in the previous step. So here's the hex file, so we'll open that. Make sure the MCU is set to ATmega 32U4. Click Auto Flash. Now you want to plug in your Leonardo into your computer, so it should look something like this. Using your USB to micro USB cable, connect your Leonardo into the computer. And then you want to click the reset button, which is in the corner of the Leonardo. Let's go back to QMK. Now my Leonardo is already inserted, and now I'm going to click the reset button. And so you'll get all these logs. So now we flashed the program. In this case, the TurboA program. Some notes for troubleshooting. If plugging in the Leonardo to the computer does nothing, and you don't get even the Windows plug/unplug sound, then try changing the USB cable. It might be a charge-only USB cable and may not support data transfer. If the QMK logs over here shows a bunch of errors when trying to flash program, try pressing the reset button again and see if that works. So next we will test the TurboA program. We want to make sure we can successfully load a program onto the microcontroller before we move on. TurboA is a simple program. It just repeatedly spams the A button. So you can test TurboA however you want. For me, I'm just going to stand in front of the Pokemon Center and use TurboA to repeatedly heal. Now I'm in the Pokemon game. I want to stand in front of the Pokemon Center. For me, there seems to be a bug with the TurboA program, so I'm just going to start in the crouching position before I start the TurboA program. So in order to start this program, you need to start in the grip controller menu. So I'll click Home, then Controller, then change grip order. Now you want to make sure your switch is docked. So it should look something like this. I recommend connecting the switch dock to a screen so you can monitor what's happening. For this video, I'm using my capture card to output the video to my computer screen so I can screen record. If you don't know how to do this, that's okay. Just connect your switch dock with your TV or computer monitor with an HDMI cable. Then to activate the TurboA program, I'll plug in the Arduino into the switch dock. The moment I plug in the Arduino, it will start spamming A. So let's do this now. So first I'm going to go back to seeing the switch. I'm going to plug in the Arduino into the switch dock. So now it's plugged in. And so now we wait for the program to start. And so now you can see that it's spamming A. To stop the program, simply unplug the Leonardo at any time. If you don't have a TV or computer monitor, you can test this out blind. Instead, you can stand in front of a Pokemart, leaving this program running for a minute, then check back if you've bought a handful of potions. Another alternative is to use a USB-C hub to connect the microcontroller directly to the switch, while still allowing you to view the screen on the switch. As I mentioned, all that we're trying to do is confirm that we can successfully flash a program onto the Leonardo and confirm that the program works. We just chose TurboA because it's a simple program and it's simple to test. Once you can get this to work, we can move on to setting up computer control. If you can't get this to work, stop and review your setup before you move on to the next steps. You can either review this video or review the official guide on GitHub. Or you can ask for help on Discord, which I'll talk about later. The link to the Discord server will be in the description. If you only want to set up microcontroller automation, you can stop here. If you want to run a different program, just repeat the previous steps, starting at the hex generator, but select a different program instead of TurboA. Once you have a working microcontroller setup, we can set up computer control. As a reminder, you need a regular switch, not a switch lite, and you need a computer that runs 64-bit Windows. Go to the GitHub wiki for part 4, computer control. Link will be in the description. The next few steps will be very similar to the microcontroller setup, except now we're flashing a different program onto the Arduino. So we'll scroll down to step 2 and download the serial programs package. So we'll download the latest version, we'll download this zip file. So you'll notice that I have it downloaded to a different folder compared to the microcontroller programs, just so that we don't confuse ourselves. So now let's extract it. Once again, make sure the extracted zip file is not located in a Microsoft OneDrive folder. Next, we will flash the program called PABotbase onto the Leonardo. So let's run the QMK toolbox program. Now open the hex named Nintendo Switch PABotbase Leonardo.hex. This will be located in the folder that we just downloaded and unzipped. So click open. So right now I'm in the folder for the microcontroller program, which is not what we want. So let's go back up and we'll navigate to the computer control program. And so here is the PABotbase for the Leonardo.hex. So we'll open that. Make sure that the MCU is set to ATmega32U4. And then we click auto flash, similar to last time. Now you want to plug your Leonardo into your computer again, like so, and then click the reset button. So I plugged in my Leonardo, and now I'm going to click the reset button. And you'll see all this logging here. Now we will set up the hardware. If you have the Adafruit USB to TTL serial cable, also referred to as the Adafruit UART cable, then connect the UART cable with the Leonardo using the jumper wires. Refer to this table and this picture shown here. So you want to connect the green wires to the RX, the white wire to the TX, and the black wire to ground. Note that the color of the jumper wires do not matter, but the color of the UART wires do matter. If you did not buy the Adafruit UART cable and instead bought a CP210X module, your colors will be different. Refer to the manual or look at the board itself for the correct pins. Often the module itself will have the pins labeled. So here's an example of a CP210X module, and you'll see here that the pins are labeled. So here's the TX, the RX, and the ground. And so you want to connect them as per this table. Connect the TX to the RX to the TX, the ground to ground. So now we will set up the rest of the hardware. The whole setup should end up looking something like this. So first you want to have your switch turned on and put in the dock. Make sure the dock is powered with its power cable. Connect the UART into the computer. We've already connected the UART cable to the Leonardo using the jumper wires in the previous step. Make sure the Leonardo is connected to the dock with its USB cable. Connect the HDMI cable to the dock as well as to the capture card, and connect the capture card to your computer. Now we want to open the serial programs.cmd file. This is located in the serial programs folder that we previously downloaded and unzipped. So we'll open that up. When you first open this file, you'll get a warning from Windows Defender. If you trust them, you can just click run anyway. So now we will open the virtual console. Under serial port, we want to select COM5 Silicon Labs. If we have this blue text here that says program PABotbase, that means it works. If, however, under this dropdown you don't see anything, or you don't get this blue text, one possible solution is that you don't have the correct drivers for your UART cable. So you can go back to the GitHub page, scroll down to step 4, and then download the drivers here. And I'm going to extract that file. And because this is a 64-bit version of Windows, we will use the 64-bit installer. Click Next, Accept, Next, and then Finish. If it worked properly, then you should now see COM5 Silicon Labs or COM whatever number Silicon Labs. You can always try clicking Reset Serial to see if you get the blue text here. Now moving on, we will now select the camera. So under this dropdown, I will click USB video. And so now you should see the output from my switch. So next we'll set up sound. In contrast to video input, only some programs need audio input, mostly the shiny hunting programs. So under audio input, you have to select the correct source. So for my case, it will be digital audio interface, USB digital audio. Audio output is completely optional. It's only if you want to have game audio coming out of your computer speakers. So I'm going to leave that alone for now. If you're having trouble with getting the audio or video to work, here are some basic things to try. So first, as I mentioned, make sure you try clicking Reset Serial. Next, you can try disconnecting and reconnecting all your wires and connections. Try different USB ports. Make sure all your connections are snug, especially between the jumper cables. You can also try rebooting your switch, making sure you're not just putting it into sleep mode, but actually shutting it down and restarting it. Next, make sure everything is connected to the correct component. So again, here is what the entire setup should look like. And here is how to connect the UART to the Leonardo. If the basics still don't work, then refer to the troubleshooting section in the GitHub wiki. You'll find this in Part 4 Computer Control under Step 6. And then you may also refer to the Discord server for help. The link is posted on this slide as well as in the video description. The Discord has a help section under Arduino-help. First, read the FAQ pinned at the very top for troubleshooting tips. If you still can't solve your issue, you can also post about your issue and someone may be able to help you. So that's basically it for setup. You can now try out the various programs. So if you click the game that you're interested in, you can see a list of all the programs in the sidebar. Within each program, there will also be a link to the online documentation, which explains how to set up and how to use the program. And I encourage you to read it for every program you do use. On the GitHub wiki page, you can also see a list of all the programs. And I'll put a link in the description. I do encourage you to briefly read about each of the programs on this list, just so you know what all the programs do, because it's not always immediately obvious just based on its name. For example, I just wanted to highlight a few programs for Scarlet and Violet. The ESP training allows you to farm the EV reduction berries, and the Flying Trial Farmer farms for blueberry points. Again, before using any of the programs, I recommend reading the documentation here on GitHub so you know how to set up and use it properly. One more feature I want to point out is that you can use the keyboard as a controller. Let's just go back to the virtual console. So what you do is you just click on this video and then you'll see that the keyboard control is now active. To see the keyboard/controller mapping, just click on keyboard layout. You can see what each button on the keyboard maps to on the controller. So as of this writing, there is no support for changing the key mapping. One use case for this is so that you can therefore play your Switch remotely if you have a remote desktop setup. So that's it for this video for setting up Pokemon automation.